Good morning again. Okay, let's go ahead and take a look at the practice. Hopefully you got a chance to work on it last night. If not, you can go over it here. And if you understand this and are ready to take the assessment afterwards, then you're welcome to go ahead and do that. Now, yesterday we worked on finding inverse functions. And in the previous video, I talked about the 3 different ways that we can find inverse functions. We can flip it on the graph. We can flip the domain and range in a table, or we can flip the equation. And sometimes we'll have to do more than one. So I have 4 examples of graphs here, and we are going to find the inverses. Now the instructions do tell me that I need to have an equation based on the information given. So I do need to have my original equation, or my original function. Then I have to find the equation for the inverse. Now I don't have to do these in this order. I may sketch it first and then find my equations, but I do need to have my inverse equation. Or I'm going to say function. That's more specific, more precise. I do need to sketch both graphs, and then I have to determine if the inverse is a function. Remember, we're going to use our vertical line test to determine that. So let's go ahead and take a look at our first one. I notice in my first one, I have nothing on the graph yet. The y equals x is sketched in just in case we need it. But I do have an equation. So I'm looking here. I have 2 choices. I can make a table with a domain and range, or I can flip the equation first. I think I'm going to flip the equation first. So what I'm going to do is I'm going to take my y and my x and I'm going to flip them. Y equals, my y is going to be up there in the numerator, and now just in case you need a short review, since this is in the denominator, this is being divided by 3. So to kind of unlock this fraction bar, I need to multiply by 3. These cross cancel and become 1s, because really that is 3 divided by 3. But whatever I do to one side, I have to do to the other. So now I have x divided by 3. Oh, wait a minute. Sorry. I have x times 3. Good thing I took a double look at that. Okay, so as a mathematician, I always rewrite my equations. I even do an RW to tell me to rewrite, because this looks kind of messy. I'm like, what do I do next? So I have 3x equals y plus 8. Because this is a 1 now, I don't need to write it. Now my next step is still to get y by itself. So I notice that this is a positive 8. I need this to be 0. So in order to make this a 0, I need to have a negative 8. They become 0. So I don't have to write them anymore. But whatever I've done to one side, I have to do to the other. So I'm going to subtract 8. Now again, I'm going to rewrite it so it makes sense to me. I have 3x minus 8 equals y. Now, as a mathematician, I prefer to see it as y equals 3x minus 8, because I know how to graph that. I also notice that I have my first original function. Oh, no, wait a minute. This is my original function. I have found my inverse. There we go. I have found my inverse. So I have done the first 2 steps. I have my original function, and I have my inverse function. Now I need to sketch them both. So what I'm going to do, I know how to sketch this real easily. So if you need to watch closely. I'm going to take that negative 8. This is my y-intercept. So I'm going to come up here to 0 and go to my y-intercept, which is negative 8. So I'm going to put a point there. I know that my slope, this is rise over run, which tells me to rise 3, run 1. So I'm going to rise 3, run 1. Rise 3, run 1. Rise 3, run 1. I have enough points now that I can go ahead and sketch in my line. And I've lost my ruler. So that's okay. That's what postcards are for. Okay, so let's go ahead and sketch in this line. Make it as precise as possible. Now, I have 2 choices here. Notice that I have sketched one function, but I have not sketched the other one. I could make a table out of this, but I also notice I already have points. look it, I have a point here at 1, 2, 3, 4, 5. I have 1 at 1, negative 5. I have a point at 2, negative 3. No, sorry, negative 2. I need my glasses. And then I have a point here at 3, comma, 1. I remember all I have to do is flip my domain and range. And I have my new coordinates. So I'm going to take each one of these and I'm going to flip them. So my inverse function will have a 1, comma 3. It'll have a negative 2, 2. And it will have a 1, comma negative 5. So now I'm going to plot those. See, that was a lot easier than solving that equation in a table. So I'm going to find my point at 1, comma 3. So 1, comma 1, 2, 3. I'm going to go to negative 2, 2. 1, 2, 1, 2. And at 1, negative 5. I think there's something wrong there. I didn't flip it. Look at that. I was like, wait a minute. Sometimes I make mistakes and I've got to catch them. So negative 5 and 1. Okay, negative 5, 1, 2, 3, 4, 5, and at 1. So now I'm going to go ahead and use my postcard again. Okay, I have two functions. I've sketched both functions. Now I just have to see if the inverse is a function. So I'm going to line up my pen and I'm just going to drag it across. And I notice that it's only touching the orange line at one spot at a time. I'm now going to look at my blue line. And it is only sketching one or touching one part of the line at a time. So this is a function. So I can make a big, yep, it is a function. Yay. Okay, first one's done. Now you see why I only have 4. It does take a little while. Okay, number 2, or I guess this is number 10. I notice here that I have slope and I have a point. This is the makings of an equation. But I realize I think I'm going to do my graphing first. So I'm going to graph what they've given me and then go from there. Now they have told me that there is a point on my line that is at negative 1, negative 4. So I'm going to go to negative 1, negative 4. 1, 2, 3, 4. And then they told me that my slope is 5. Remember, that is rise over run. So 5 over 1. So I'm going to rise 5. 1, 2, 3, 4, 5, and run 1. 1, 2, 3, 4, 5, run 1. Now, I think this is really cool. Look what happened. There is a point right here on the y-intercept. That means it's my y-intercept. Okay, so my y-intercept is positive 1. It's at 0, 1. That's going to be important here in a minute. That's how we write our equation. So I'm going to go ahead and sketch in my first line. Okay. Now I have two choices. Remember, I have got my line, but I've got to sketch my other one. So I can go ahead and just flip it real fast. So notice here I'll point at negative 1, negative 4. I have a point at 0, 1. And I have a point at 1, 1, 2, 3, 4. Is it 6? 1, 2, 3, 4, 5, 6. 1, 6. That means my inverse is going to be the flip of that. So my inverse is going to have a point at 6, 1, 1, 0, and negative 4, negative 1, making sure I did all my flips, unlike my last one. Okay, so now let's go ahead and plot these points. 6, 1, 1, 2, 3, 4, 5, 6, and a 1. And then 1, 0. So 1, 0. And then negative 4, negative 1. 1, 2, 3, 4, negative 1. Now, I'm going to go ahead and sketch that line. Okay, so notice in this one, I have sketched my graphs first. Now I'm going to work on equations. Now, all the information I need to write an equation for my original is right here. Remember that equations are written as y equals mx plus b. Now, b is my y-intercept. It's that 1, so it's a positive 1. My slope was given to me in the problem, so that is 5x equals y. There is my original equation. Now I do need to find the inverse. So I'm going to do step 3, flip the equation by switching my x and my y variables, then solve for y. So let me go ahead and get my pencil. I'm going to switch my y and my x. X equals 5y plus 1. Now remember, our goal is I need to get this y by itself. So my positive 1 needs to be a 0. To make it a 0, I'm going to subtract 1. That's a big 0. So I'm going to subtract 1. I'm going to rewrite, just so it makes sense, 5y equals x minus 1. Don't forget that negative 1. And now I need my coefficient to be a 1, so that y can be by itself. You can make any number a 1 by dividing by itself. Remember, it becomes a 1. So I no longer see it. It is just y. But since I divided this side by 5, I'm going to divide this side by 5. Now, I am actually going to rewrite this as a mathematician would. I'm going to put the y equals x minus 1 over 5. So, there is my second equation, my inverse. So, original equation, inverse equation, original graph, inverse graph. Actually, I think I flipped that. And now we get to determine, is it an inverse function? I'm looking at this at the same time, and yes, both lines are inverse functions, so they are functions. Okay, now I'm going to pause this because this is kind of already a 12-minute video. I will take a break, and then I will do the second two.